Hi, I'm Dana Maier, and this is my Week 2 assignment for Material and Methods 2, and this is on the basics of metal. First, we're going to talk about sustainability in steel frame construction. With steel, it can be reused and recycled repeatedly without ever losing its qualities as a building material. This unique characteristic gives all steel a high economic value at all stages of its life cycle, which, unlike some other construction materials, ensures that it is routinely recovered and reused. Steel's material properties make it the ultimate sustainable construction material, both in terms of its material properties and the credentials of the steel-framed buildings. Its superior strength-to-weight ratio means a little steel goes a long way, giving architects complete flexibility to innovate and create new and exciting buildings that are a pleasure to live and work in. Sustainability, green buildings, is our next topic. Steel is one of the most sustainable building materials in the world. The industry has embraced the common sense approach that reducing its impact on the environment is not only the right thing to do, but it makes economic sense. Since the early 1990s, the steel industry has reduced its energy use to produce a ton of steel by approximately 1/3. More than 95% of the water used in the steelmaking process is recycled and returned, often cleaner than when it was taken from the source. Now for sustainability. Structural steel. It's the premier green construction material. Structural steel is a premier green construction material. Its high recycled content and recycling rate exceed those of any other construction material. Over the past 3 decades, the steel industry has significantly reduced greenhouse gas and overall emissions. While numerous legislative and regulatory efforts in recent years have targeted emissions, energy efficiency, and related environmental concerns, the structural steel industry has been proactive in pursuing measures that typically exceed regulatory requirements. As the green building movement grows, more and more building owners, architects, engineers, and contractors are realizing the benefits of selecting structural steel framing systems as a means of meeting sustainable design and construction goals. The LEED Green Building Rating System, developed by the U.S. Green Building Council, has been crucial to this movement, and under LEED 2009 and V4 criteria, structural steel receives maximum credit for its contribution to the overall rating for a structure, due in large part to its recycled content, recycling rate, and transparency. Structural steel produced in the United States contains 93% recycled steel scrap on average. At the end of the building's life, 98% of all structural steel is recycled back into new steel products, with no loss of its physical properties. As such, structural steel isn't just recycled, but multi-cycled, as it can be recycled over and over and over again. It is truly cradle-to-cradle material. Now for some history. The use of steel for structural purposes was initially slow. The Bessemer process in 1855 made steel production more efficient, and cheap steels, which had high tensile and compressive strength, plus good ductility, were available from about 1870, but wrought and cast iron continued to satisfy most of the demand for iron-based building products, due mainly to problems of producing steel from alkaline ores. These problems, caused principally by the presence of phosphorus, were solved by Sidney Gilchrist Thomas in 1879. It was not until 1880 that an era of construction based on reliable mild steel began. By that date, the quality of steels being produced had become reasonably consistent. We will now talk about the material steel. First, with steel alloys. Alloy steel is steel that has been alloyed with a variety of elements in total amounts between 1.0% and 50% by weight to improve its mechanical properties. Most commonly, the phrase alloyed steel refers to low alloy steels. every steel is an alloy, but not all steels are called alloyed steels. The simplest steels are iron, alloyed with carbon, about 0.1% to 1% depending on the type. However, the term alloy steel is a standard term referring to steels. Now to the production of structural shapes. Structural steel is a category of steel used in making construction materials in a variety of shapes. Many structural steel shapes take the form of an elongated beam having a profile of a specific cross-section. Structural steel shapes, sizes, chemical composition, mechanical properties such as strengths, storage practices, etc. are regulated by standards in most industrialized countries. Most structural steel shapes, such as I-beams, have high second moments of area, which means they are very stiff in respect to their cross-sectional area and thus can support a high load without excessive sagging. Common structural shapes. We have listed a few here. We have the I-beam. It's an I-shaped cross-section. In Britain, these include universal beams and universal columns. In Europe, it includes the IPE, the HE, HL, and HD, and other sections. In the US, it includes the wide flange and H sections. We also have the Z shape, half a flange in opposite directions. There is HSS shape, hollow structural section, also known as SHS, structural hollow section, and including square, rectangular, circular, and elliptical. There is the angle, an L-shaped cross-section, the structural channel, or C-beam or C cross-section, and the T, a T-shaped cross-section. We also have the rail profile, an asymmetrical I-beam. Under that, you have the railway rail, Vignol's rail, flange T-rail, and grooved rail. There's the bar, a piece of metal, rectangular cross-sectioned and long, but not so wide, so it has to be called a sheet. There's a rod. It's a round or square and long piece of metal. You can also see rebar and dowel. There's the plate. There are metal sheets thicker than 6 millimeters or 1/4 inch. There is also the open web steel joist. Now we will talk about cast steel. Cast steel usually refers to normal carbon steel and alloy steel, or also called steel casting, with carbon content lower than 2%. Therefore, no big difference considering from the chemical content and raw materials for cast iron versus cast steel. One of its big advantages is design flexibility. We will now talk about cold worked steel. The advantages are there is no heating required, better surface finish obtained, a superior dimension control, there's better reproducibility and interchangeability of parts, improved strength properties, and directional properties can be minimized. Disadvantages to the cold worked steel are higher forces required for deformation, heavier and more powerful equipment required, less ductility available, the metal surfaces must be clean and scale free, strain hardening occurs, which may require intermediate anneals, and imparted directional properties may be detrimental. We will now talk about open web steel joists. Open web steel joists, also shortened for OWSJ, is a lightweight steel truss consisting, in the standard form, of parallel cords and triangulated web system, proportioned to span between bearing joints. The main function is to provide direct support for roof or floor deck and to transfer the load imposed on the deck to the structural frame, i.e. the beam and the column. Engineers consider the joist span between bearing points, joist spacing, slope, live loads, dead loads, collateral loads, seismic loads, wind uplift, deflection criteria, and maximum joist depth allowed. We will now talk about the joining steel members. A gusset plate can be fastened to a permanent member either by bolts, rivets, or welding, or a combination of the three. Gusset plates not only serve as the method of joining steel members together, but they also strengthen the joint. They are used in bridges and buildings as well as other structures. Now we will talk about shear connections and moment connections. Shear connections, the bolts on the web beam are in double shear. Double angles are shop welded to the web of the beam. This is a shear connection since the double angles are fastened to the web and transfer the load in the shear. With moment connections, it is a welded beam to the column. The beam flange welds transmit full flange strength to the column. The shear tab, welded to the column and bolted to the beam web, support the beam until it is welded and offer permanent shear resistance. We will now talk about the construction process. First, we have the fabricator. Metal fabrication is the building of metal structures by cutting, bending, and assembling processes. Pre-stressing may be achieved either by pre-tensioning or by post-tension. And the steps in the process are cutting, bending, and assembling. Next, we have the erector. Steel erectors assemble scaffolds and structural components made from steel. They are part of a larger group of construction workers, and they are critical members of the team on extremely large structures that require steel framing for safety and integrity. Next, we have fireproofing of steel framing. Originally, this was done by encasing steel beams and columns in brick masonry or poured concrete. These heavy encasements were effective, absorbing heat into their great mass and dissipating some of it through dehydration of the mortar and concrete, but their weight added considerably to the load that the steel frame had to bear. Longer spans in steel. This we will talk about is improved beams. Improving the junction point of the beam and column by providing ductile reinforcement, which helps to resist lateral movement. It also, with this, can resist earthquakes. We'll now talk about arches. The arch is useful because many building materials, including stone and unreinforced concrete, can resist compression, but are weak when tensile stress is applied with them. An arch is held in place by the weight of all of its members, making construction problematic. Several types of arches are circular and semicircular, horseshoe, pointed, parabolic. We will now talk about tensile structure. It is a construction of elements carrying only tension and no compression or bending. Most tensile structures are supported by some form of compression or bending elements, such as masts. A tensile membrane structure is most often used as a roof, as they can be economically and attractively span large distances. Now for fabric structures. Fabric structures are tensile structures in which a membrane is stretched to form three-dimensional surface that can be used to create a roof, shading, or decorative component. Sometimes described as modern tents, fabric structures use very little material compared to other forms of construction and are typically translucent, but they provide little thermal mass or insulation, and they can have a shorter lifespan than some other materials. Composite columns. They are a combination of two traditional structural forms, structural steel and structural concrete. As composite columns are generally developed after steel columns and reinforced columns, their design approach could have been based on either steel or concrete design methods. Industrialized system in steel. The industrialized building system, or IBS, can be defined in which all buildings, such as a wall, a slab, beam, column, and staircase, are mass-produced either in a factory or at a site factory under strict quality control and minimal wet site activities. The uniqueness of steel. Some of the qualities are corrosion resistance, fire and heat resistance, and strength to weight advantage. We will now talk about the I-beam versus wide flange, or also the H-beam. An I-beam has narrower flanges than the H-beam. The geometric difference in flange to web ratio. The H-beam would have a flange width of more than the web height. An I-beam would have a smaller flange width comparing to web height. Here is a diagram of the angle versus the channel versus the T to give you an idea of the differences. We will now talk about plate versus gusset plate versus bar. The plate they are structural plates with a higher yield and tensile strength. It can be obtained by specifying ASTM A572 grade 42, 50, 60, or 65, or ASTM A20, A529 grade 42 or 50, ASTM A514 grade 90 or 100, or ASTM 852. With gusset plate, they are triangular plates of steel that are used to connect beams and girders to columns. With the bar, comments for structural plates apply equally to the structural bars, except neither ASTM A514 and not A852 are applicable. Here are some diagrams of the metal roof decking. We have the B deck, which has 36-inch coverage, an F deck, which also has 36-inch coverage, an N deck, which has 24-inch coverage, and an A deck, which has 30-inch coverage. We will now talk about cellular decking versus composite decking. Cellular decking is when the cellular floor deck with continuous or underside beaded linear panel allows for increased deck spans, increased clear spans, it's unshored, and increased cantilever spans over non-cellular types. It is available with acoustical cellular deck option, fiberglass insulation bats installed in the deck cells at the factory under controlled conditions. Composite metal decking is when the composite steel floor deck has a ribbed profile with embossments designed to interlock with concrete slabs, creating a reinforced concrete slab that serves the dual purpose of permanent form and positive reinforcement. And there we have to end things up, the list of the references. Thank you.